Okay, we're going to start off with a word that you should have heard before, so let's talk about it. The word is operation, and in math we have some operations that we use. You've already learned 4 of them, and so let's talk about what those are. What are the operations in math? Well, the first one you probably learned was addition, and then subtraction, and then multiplication, and then division. So those are the 4 operations in math, and there are others that you'll learn in the future, but for now those are going to be the 4 that we talk about when we talk about the operations in math. Now, what we're going to do is we're going to take a few minutes to review some things that have to do with operating on numbers. In particular, we're going to be looking at some strategies you can use to make doing operations on numbers a little easier. So let's talk about, first of all, multiplication. Let's say you're multiplying 200 times 120. Alright, there's a lot of different ways to do that problem, but one way is to notice, first of all, that the first number, 200, has 2 zeros, and the second number, 120, has 1 zero. Alright, so because of that, we know that our answer is going to have a total of 3 zeros. Alright, and then to get the other part of our answer, all we have to do is multiply the 2 times the 12, which is 24. Okay, so the answer is 24,000. So really, all we had to do in this problem was multiply the 2 times the 12 to get 24, and then we had to just tag the correct number of zeros, which in this case is 3. Alright, so you can use that, and be sure you do use that because it's going to be very helpful to you in doing problems. Now, I also want to talk about division. Let's just say that you had this problem, 28 divided by 4 equals 7. Okay? Now, what I want to remind you of is that whenever you have a division problem, the answer, which we call the quotient, if you take that number and multiply it by the divisor, which is 4 in this case, 7 times 4, you should get the dividend, which is the first number in the division problem. So in other words, if 28 divided by 4 equals 7, we also know that 7 times 4 equals 28. So these two numbers, when multiplied together, give you the first number. Well, we're going to use that idea in order to solve a division problem. Let's just say we have 5,600 divided by 70. Alright? And of course, there's some answer to that. Now, if you remember, if we multiply the 70 times the answer, we should get 5,600. So let's write that. 70 times my answer is going to equal 5,600. Now let's think about what we just talked about with multiplication. First of all, I noticed that my answer has 2 zeros. And so my two numbers that I'm going to multiply together, I have to have a total of 2 zeros. Well, I only have 1 zero here, so I need another 0. And then the other thing that I want to notice is that this number is 56, and I have a 7 here, so I need to have 7 times something equals 56. 7 times 8 is 56. So 70 times 80 is going to equal 5,600. Therefore, if I go up to the previous problem, I know that 56 100 divided by 70 has to equal 80. Alright, so I'm using multiplication to do a division problem, because multiplication and division are what we call inverse operations, and that just means they're kind of like the opposite of each other. They're inverse operations. You can use one kind of to undo the other one. So you can use this property that we've learned to find the answer to a division problem by using a multiplication problem. Okay, now we're also going to talk about some strategies for addition. Okay, so first of all, let's look at this problem. Let's say we have 76 plus 120 plus 65. Alright, now there are different ways you can go about this problem, but I want to show you a couple of things that you can do to make this problem a little bit easier. Alright, one thing that you can do is you can notice that you can rewrite 76 as 70 plus 6. So you're breaking it down into its parts. Alright, now we're going to leave 120 like it is, and then we're going to break 65 down into 60 plus 5. Alright, now when we're adding, notice we have addition all the way through this problem. There's no other operation, there's only addition. And so when we have only addition, we're allowed to move the numbers around in any order that we want. So in other words, I can rewrite this problem as 6 plus 5 plus 70 plus 120 plus 60. Alright, now I've written the same 5 numbers down, but I've put them in a different order. But I'm allowed to do that as long as I have addition all the way through, which I do. Alright, now why would I write them in a different order? Well, some of the numbers might be easier to add together than others. So I'm going to add the 6 plus 5 together and get 11. Alright, I'm going to add the 120 plus 60 together. That's going to give me 180. And then I still have this 70 here. Alright, so now I would like to add the 70 and the 180, which is 250, and plus the 11, and so that's going to give me 261. Alright, so what I've done here is I've used a couple of properties. One is that I can rewrite my numbers. In other words, I can break them up into their parts. The 7 in 76 actually means 70, and the 6 means 6. Okay, and I broke down 65. The 6 actually means 60, and the 5 means 5. And then I reordered my numbers and added together the ones that I wanted to, and got my answer. Okay, so that's one way of doing it. Alright. Another way of looking at it is to look at place values. Okay, so let's take that same problem. Okay, and see if I can do a little better with that. Okay, alright, so now let's think about what place values are in each one of these numbers. The 7 here is actually 7 tens. And 6 ones. The 6 is 6 ones. Alright? And on the 120, that's 100. And the 2 is 2 tens. And the 0 is actually 0 ones. And then the 6 here is 6 tens. And the 5 is 5 ones. Now, we can add together the things that are alike. So we have 100. That's the only 100 we have. Okay. And we have 7 tens, 2 tens, and 6 tens. That's a total of 15 tens. And then we have 6 ones and 5 ones. That's 11 ones. Okay. Now we have to also remember before, when we try to write our final answer, that for instance, when we have 11 ones, that's actually 10 plus 1. Alright, so that's 10 ones plus 1 1. Now 10 ones is actually 1 10. Okay, because that's 10 right there. Alright, now, so let me just copy that down. Now let's look at our tens. We have 15 tens. Well, 15 tens is actually 10 tens plus 5 tens. Well, 10 tens is 100, isn't it? I'm just going to abbreviate that. Okay. And then we have this 100 that we already had right here. Alright, now, so what do we have? Well, we have 100 plus 100, that's 200s. Okay, plus we have 5 tens plus 1 10, that's 6 tens. And we have 1 1. So what number is that? Well, that's 261. Same answer we got before, but this is doing it by kind of looking at place values. Alright? And so, in other words, you can add all your hundreds together, all your tens together, and all your ones together, and then get your answer that way. Okay, so what we've noticed here is that place value is very important for us to understand. We also have talked about how when you're adding, if everything is addition, that you can move numbers around into any order that you want. Okay, in other words, order doesn't matter. But if you have more than one operation, let's just say you have addition and multiplication together, or if you have division and addition together, 2 different operations, or maybe 3 or 4 different operations, then you have to use something called the order of operations. Now, I know you've heard of this before, so let's just review it. Okay, what is it? Order of operations. Well, the order of operations just tells you what order you need to do a problem in when you have more than one operation. So the rule is that first you always do all your multiplication and division from left to right. Alright, and then after you've done all your multiplication and division, then you can do your addition or your subtraction, also from left to right. Okay, so basically the order of operations just says you must do all your multiplication and division before addition and subtraction. Alright, so if you have a problem that has multiplication and division along with addition or subtraction, you have to do all the multiplication and division first. Then you can do your addition and subtraction last. Okay, so let's look at a couple of examples. Let's say we are multiplying 90 times 80 minus 10 times 70. Alright, now notice we have multiplication and we have subtraction, and we have multiplication. So we have a mixture of operations. So we have to think about the order of operations. Order of operations says we need to do all multiplication or division first. Okay, so we have to do this first. That's a multiplication. And this is a multiplication. We can't do the subtraction until we've done all the multiplication and or division, if we had it. Alright, so what's 90 times 80? Well, 9 times 8 is 72, and I have 2 zeros that I need to tag on. And then minus 10 times 70, well, 1 times 7 is 7, and I have 2 zeros. So I get 7,200 minus 700, and if I subtract, I get 6,500 for my answer there. Okay, so again, I had to multiply first, then I was able to subtract. So here was my original problem, and then in this step, I did all my multiplications, and I would have done divisions if I had those. And then in this step, my last step, I did my subtraction. Okay, let's look at another example. Let's say we have 4,500 divided by 5 plus 20 times 80. Now in this problem I have 3 operations. I have division, I have addition, and I have multiplication. So I have to do all my multiplication and division first. So I have to do this first, division, and this multiplication. And I always go from left to right, so I'll do the one on the left first. 4,500 divided by 5. Well, remember now, to get that answer, I'm asking myself what number times 5 will give me 4,500. Well, I know there's going to have to be a 9 there, because 9 times 5 is 45. And I'm going to have 2 zeros, because 900 times 5 will be 45 with 2 zeros, which is 4,500. Okay, bring down your plus sign. And now we're going to multiply 20 times 80. 2 times 8 is 16. And tag 2 zeros. Alright, so I've done all my multiplication and division. Now I can do my addition. So I have 900 plus 1600. That's 2,500. Okay. Alright, one more example. Let's say we have 10 minus 2 times 3. Okay, now that looks like a pretty easy problem, but a lot of people will make a mistake on this problem because they'll do the subtraction 10 minus 2 first. And we can't do that because of order of operations. Order of operations says we have to do all the multiplication or division first. Then we can do addition and subtraction. Alright, so we have to do multiplication in this case first. So our next step will be 10 minus 2 times 3 is 6. And then we can do the subtraction. So 10 minus 6 is 4. Alright, very important to remember your order of operations in order to get the correct answer. Okay, now whenever you're doing problems that have more than one step, which most of the problems you're doing at this stage now have more than one step, be sure you use the proper format where you write the problem down and then you do one step at a time and you show all your work. Even though you can do it all in your head, you want to show all your steps. Okay, it's really important in math to be able to show all your steps. You'll see why as you get into harder and harder problems, it's going to be more and more important. But for now, even if the problem is easy, be sure you show all of your steps and all of your work. Alright, so let's move to another idea here. We're going to be looking at a chart, and you'll have a couple of these to do in your homework. And you're going to see something like this, and then you will see an N, and an N just is a letter that stands for a number. Okay, we use N because it's the first letter in the word number. So N is some number, and then N plus 5 means you take the number and add 5 to it. Okay? So if I take a number like 3, okay, if 3 is my n, then what is n, my number, plus 5? Well, my number is 3, so n plus 5 is 3 plus 5, so that's going to equal 8. Okay? Alright, so now, what if my number is, let's say, 7? Alright, now n is 7, so what is n plus 5? Well, it's 7 plus 5, so this is going to be 12. Alright, so let's say I have another number. Let's say I let n be 10. Okay, so now n plus 5 will be 10 plus 5, which is 15. Alright, and so on. I could keep on putting numbers in here. Let's say I put 12 for n. So now n plus 5 will be 12 plus 5, which is 17. And let's say I let n be 20. Well, then n plus 5 will be 20 plus 5, so this will be 25. Right? Now, whenever we have a chart like this, and we have something that looks like this at the beginning, this is called the rule. Alright, so every time you are figuring out what numbers go in the boxes, you always go back to this rule right here. And the rule says that the number on the bottom, to get the number on the bottom, you take the number on the top and add 5 to it. Alright? So we'll do a few of those, and you'll do a couple of those for homework. So let's look at another one. The thing about these rules is you have to make sure that whatever the rule is, it works for all of the numbers. Alright? So let's just say I have this rule. I have n, and I have n times 3. Alright? So let's look at a couple of examples. Alright, let's say I let n be 2. Alright, so then to get the number under it, it's going to be n times 3, and n is 2, so it's 2 times 3, so this will be 6. Okay, now if my n is, let's say, 3, now my n is 3, so the number below it is going to be n times 3, or 3 times 3, this will be 9. Okay, let's say my n is 5. So the number below, under the 5, will be n times 3. N is 5, so it'll be 5 times 3, so this will be 15. And just one more, let's say n is 10. Alright, so the number below the 10 will be n times 3. N is 10, so 10 times 3, that'll be 30. Alright, so if you're given the rule, you can come up with the numbers that go in the chart. Alright, so you'll be asked to do that, and then sometimes you will be given the numbers and they will ask you to come up with part of the rule. So let's look at a couple of examples like that. And this, sometimes you have to be careful on these, so I want to show you how that can be the case. Alright, so let's say that I have n here, and I have 23, and I have 19, right? And I have 47 and 43, and I have 56 and 52. Alright, and I want to come up with what goes in this box right here. Alright, so I'm coming up with basically the rule. Alright, so what I have to do is I have to look at the numbers and see how they are related to each other. So if I look in the first column here, n was 23, and so the number below it is 19, which is a smaller number. So to get a smaller number, usually you have to subtract or maybe divide. Alright? So if I take my n, which is 23, and I subtract 4, I'll get 19, won't I? Okay? So I could say that this might be n minus 4. But I have to check it to make sure it works for all of the columns. Alright, so let's look at the next column right here. Does it work for that one? In other words, if n is 47, if I do 47 minus 4, do I get 43? Yes. So it checks for those. So let's check this last one. Okay, if n is 56, and I put 56 into n minus 4, 56 minus 4, do I get 52? Yes. Okay, so this must be my rule, and that one is done. So let's look at one more example. All right. And again, we're going to try to find the rule. So I'm going to give you the numbers. Let's say the first one is 36 and 4, and then 18 and 2, and 27 and 3, and this is n, and we're trying to figure out what goes here. So we're trying to figure out our rule, basically, for the numbers. Now, if you'll notice the first box, or set of boxes here, we have 36 and 4, and of course the number below is less. The 4 is less than 36. So, it might be that we're subtracting, or it might be, that we're doing something else. But let's think about subtraction first. If it's a subtraction rule, then we would have to take the number of the top, which is n, and take away, we had 36, we'd have to take away 32 to get 4. So that would work for the first one. Alright? But would that work for the second one? Okay, here. In other words, if n is 18, and we use this rule, we would have to take 18 minus 32. That would not give us what we have here, which is a 2. So it doesn't work for that one. It also does not work for this one. Okay, so we have to rethink this, alright? Because the rule has to work for all of the cases. Alright, so what else can we do other than subtraction to get a number smaller? Well, how about division? So let's look back at this first case here, 36 and 4. If n is 36 and we take our n and let's say we divide it by 9, okay, will that work? So for the first case, 36 divided by 9 is 4. That checks. Alright, now let's look at the second case. If n is 18, we take 18 and divide it by 9. Do we get 2? Yes. Alright, and third case, if n is 27, we take 27 and divide it by 9. We do get 3. Alright, so all those check out, so this must be our rule. Alright, so you just have to be sure that whatever your rule is, that it works for all the cases, not just one of them. You always want to check and make sure it works for all. Sometimes you'll find a rule that'll work for one, but it won't work for the rest, and so that won't be the right answer. You have to find one that works for all. Okay, last thing I want to talk to you about today is word problems. Alright, now you're always going to have word problems in most of the sections that we do. Okay, and so we want to review some of the strategies for doing a word problem, because sometimes those can be a little bit more difficult, but they're not impossible to do. You just have to be a little more patient and to use some specific strategies. All right, first, when you're doing a word problem, remember to read the problem carefully. All right, so that means you need to slow down a little bit, read it slowly, and sometimes you'll have to read it, most of the time you'll have to read it more than once. All right, so first I would say read the problem, and then the second time you read it, you read the problem and then write down, as you're reading it, write down the important information as you read it. Okay? So you're summarizing it. Okay, so jot down the important information. All right, now third thing to remember is to draw a picture, if possible, or some sort of diagram. Okay? And number 4, notice your units in your problem. All right? If you have inches or feet or centimeters or meters or grams or pounds, whatever those units are, you want to look at those and notice those, because remember now, if you don't have the same units, you can't add things together, or actually you don't want to multiply them either. You want to have similar units before you start doing operations on them. So for example, let's just say that you had a problem that had you had 8 centimeters and you had 2 meters. All right, you cannot add those together because your units are not the same. So what you're going to have to do is convert one of those so that it matches the other one. All right, so what I'd probably end up doing is thinking about, okay, what I've got to think about is, okay, how many meters are in a centimeter, or how many centimeters are in a meter? All right, well, you want to imagine those in your mind. First of all, a meter, remember, is like a yardstick, a little bit longer, and a centimeter is a smaller unit. It's about the width of your small finger. And so we want to try to remember, if you have 1 meter, that's how many centimeters? Well, if you remember, it's 100 centimeters. Okay, so there's 100 centimeters in 1 meter. So we can use this to convert what we have up there. So we have 8 centimeters. Well, first of all, let's look at the 2 meters. How do we convert 2 meters to centimeters? Well, if 1 meter is 100 centimeters, 2 meters is going to be 200 centimeters. So if we're adding 8 centimeters plus 2 meters, that's 8 centimeters plus 200 centimeters. Now we have the same units, so we can add those together, and so that would be 208 centimeters. Okay, so again, keep in mind that you want to notice your units, and if they're not the same, you might want to convert those to the same units so that you can do the problem. Alright, now the last thing to remember about word problems is to show all your work. Okay, don't just write the answer down. Be sure to show all your work, all your steps. If you have a picture that you had to draw, show that. Show everything so that we can look at that. In case you miss it, we want to see what you did so we can figure out where you went wrong. Okay. Also, even if you get the right answer, you need to be able to show how you got your answer. That's part of what math is being able to show how you got your answer, not just getting the answer. All right, so your homework then is going to be page 10 and 11 in your text. So I will see you tomorrow.